Good morning. How are you? Hope you are all in the pink of health and you are watching bond making and bond breaking channel. Today's topic is nucleophilic substitution reaction. What I said? Nucleophilic substitution reaction. Nucleo means nucleus. Philic means love. So the love on the nucleus, that means it is Nu negative, because we know nucleus is a positive part and always it's want to attract the negative charge. So this is Nu negative. So this is nucleophilic. Nucleophilic, the love for nucleus, the philic for nucleus, that is called nucleophilic. Substitution reaction. Substitution reaction means this is nucleophilic. It attacks to this R. It attacks to this R and the leaving group is removed from here. When Nu minus attack this R, X is removed from here. So the compound is NuR. So this reaction is called, this is substitution. So this reaction is called nucleophilic substitution reaction. Okay. We can classify this nucleophilic substitution into two parts. One is SN1 and another is SN2 reaction. SN1 reaction and SN2 reaction. So SN1 reaction and SN2 reaction. So give some example of nucleophilic. Just like there are so many nucleophiles such as OH minus, H minus, OR minus, I minus, CN minus, NO2 minus. So OH minus, H minus, OR minus, I minus, this type of nucleophiles are called monodentate, and CN minus, NO2 minus, this type of nucleophile is called ambidentate. Monodentate means they can donate one electron to perform this nucleophilic substitution reaction, and ambidentate means C triple bond N, C 1 2 1 2. Nitrogen has 5 electrons in the last cell, 1 2 3 4 5, and this is minus. So N can donate its lone pair and carbon can donate its negative charge. So this is called ambidentate. So there are some nucleophilic substitution reactions. Let's see. This is Rx. It reacts with NaOH. What's happened? The nucleophile is OH minus. So OH minus attack this R. OH minus attack this R. So X is removed from here. So ROH is formed. So ROH is formed. Similarly, H2O means OH and H. So the negative terminal is OH minus, and OH minus react this R. X is removed from here. So ROH is the next. Now we take Rx and NaOCH3. So Na plus and this part is negative. So this negative terminal attack this R and X is removed from here. So the product is ROCH3. NH3 we can write in this way, NH2 and H. So this is H plus and NH2 minus. NH2 minus attack this R and X is removed from here. So the product is RNH2. So the product is RNH2. Okay. Now Rx reacts with KCN. KCN means K plus and Cn minus. Cn minus attack this R and X is removed, so the product is RCn. RCn. Ag plus and Cn minus, and when Cn minus attack this R, X is removed from here, so the product RCn. But when the reagent is AgCn, the product is NC, that is isocyanate. Okay. When you used for substitution reaction KCN, the product is RCN, and when you used AgCN for substitution reaction, you get isocyanate, that is NC. Similarly, KNO2, that is K plus and NO2 minus, when NO2 minus attack this R, X is removed, so the product is RNO2. We can write in this way, RONO. Similarly, Ag plus NO2 minus, when NO2 minus attack this R, X is removed from here, so the product is RNO2. Lithium aluminum hydrate, RX with lithium aluminum hydrate. Lithium aluminum hydrate gives H minus ion. When H minus attacks this compound, X is removed from here, so the product is RH. This is plus and this is negative. So when R minus is attack this R, X is removed from here, so the product is R minus. So those are the simple example of nucleophilic substitution reaction. Okay, hope you understand. Now we are going to discuss about the SN2 reaction. SN2 reaction. Look, 2 means by, N represents a nucleophile or nucleophilic, and S represents a substitution reaction. So this is bimolecular because of 2, bimolecular nucleophilic substitution reaction. Bimolecular nucleophilic substitution reaction. Okay. You know about the chiral carbon. Chiral carbon means the groups of the carbon of their 4 hands are different. If the elements are different, then this carbon is called chiral carbon, and this chiral carbon is required for the SN2 reaction. Okay, what happened? This is carbon H R. So this is the 3 hand of the carbon and this is X. Okay, you want to attack with the nucleophile. Nucleophile attack this carbon and X is removed from here. So the product, for a few seconds, this transition state is formed. After this, the product is inversion. Okay, this compound in this way, we show it, the product compound is in this way, and when nucleophile is attacked here, the compound is removed, is inverse in this way. So the position of this compound are in this way, in front of this way, and when nucleophile is attacked here, the inversion is occurred. So the nucleophile, so Nu and carbon H R and this is test. So this is the mechanism of SN2 reaction. Okay. Important points of this reaction. Important points are the rate of this reaction. The rate of this reaction is depending on the, we know that R means K into Rx, what I used, and then UP. Rx means Rx, and you use this nucleophile and it attack to the R and X is removed and the product is RNU. So the rate of the reaction is always depend on the reactant which you have used. So Rx and Nu are the reactants. So the rate of the reaction K, rate constant, into Rx and Nu. Rx, Nu. So this is 1 and this is 1. So the order or molecularity equal to 1 plus 1 equal to 2. So molecularity order of this reaction is 2. So this sign is representing here. Great. Next the point is, this is single step reaction. This is very important. This is single step reaction. Weak nucleophile is working here. We can use weak nucleophile for this reaction. And the third point is rate of this reaction. Rate of the reaction is inversely proportional to the steric hindrance. Steric hindrance means, it means 0 degree is good for this SN2 reaction compared than 1, 2 and 3. If you have this group CH3Cl, that means CHHHCl. So this is 0 degree compound. 1 degree means CH3HHCl. So the number of bulky group is 1. So this is 1 degree. For the SN2 reaction, 1 degree is more favorable than 0 degree. Sorry, 0 degree is more favorable for compared than 1 degree. So 3 degree is bad for this reaction, and 0 degree is the best for this reaction. As well as 1 degree is also very good for this reaction compared than 2 and 3. Okay. Though there is a point, though this group has not chiral, this group this carbon is not chiral carbon, but it is working for less steric hindrance. Now, if you ask me this question, suppose you have C, R dash, H and X. This X, if you ask me Cl or C, R dash, H and I, I give you these two compounds. And if you ask me what is good for SN2 reaction, so it is depending on this group. So good leaving group good leaving group is good for SN2. We can compare in this way. So you should look on 0 degree, 1 degree, 2 degree and 3 degree, as well as you should look on steric hindrance. Where the steric hindrance is more, SN2 reaction is weak, or SN2 reaction is not good for that, and you should look on the leaving group. Okay. And good leaving group means the bond length is high. If the bond length is high, so the leaving group is good, because to break the bond we use minimum force. So the radius of that atom is high, so the bond length is high. As the bond length is high, that is the good leaving group. For this reason, chlorine and iodine, when we compare these two elements, iodine has larger radius, iodine has larger bond length, so the iodine is good leaving group for this reaction, and that's why this group shows good SN2 reaction as compared to this. So this is the simple SN2 reaction. Okay. Now SN1 reaction. Now SN1 reaction. SN1 reaction means, one means uni. Uni means the rate of this reaction is depending on only the factor of Rx. It is not depending on the nucleophile. So the molecularity of this reaction is 1. So the molecularity of, or the order of this reaction is 1. What I say on SN2 reaction, this is a single step reaction on that case. But for SN2 reaction, this is the two-step reaction. Two-step reaction. Okay. If you take C, R, R dash and H, you take this, and then you used polar protic solvent. Polar protic solvent. But for the SN2 reaction, you can use polar aprotic solvent. Then what's happened on the reaction? You get this point. You can write in this way. You get this point. This is the trigonal form. So then it shows two type of attacks. If you take font attack, so the compound is font attack. So the nucleophile attack on this position, so the compound is this, and there is a chance it attack back attack. There the compound is a nucleophile, NuC. Okay. This is the inverse image. If you imagine a mirror, then the compound is, this compound I write in this way. C, 3 bonds here, and this is nucleus, and it is mirrored. If you imagine, then the product is NuC. So this plus and minus compound, D plus or D minus compound, these two type of mixture of this reaction is called racemic mixture. So racemic mixture is formed in SN2 SN1 reaction. Okay, you can attack on front. If you attack on front, you get this. You can attack on back. If you attack on back, you get this. It is not that we get it separately. We get on the same reaction. So the two mixture of this reaction is called the racemic mixture. You use here polar and protic solvent, where when we use on SN2 reaction polar and aprotic solvent. This is two-step reaction, but the SN2 is one-step reaction. Similarly, 3 degree is good, 3, 2 and 1. So the 3 degree is good for SN1 reaction. So these are the simple method. Okay. Hope you understand. Now we take elimination reaction. Elimination reaction. Elimination R into N. Elimination reaction. Elimination reaction means now you take CH3 CH2X. You take this compound, and when you used alcoholic KOH, what's happened? X, and you write this compound in this way, H, and HX is removed from here. So double bond in two compounds. So this reaction is called elimination reaction for the elimination of this HX compound. So the side product is HX. Okay. Important of this reaction, just very important. CH2 CH2X. If you use aqueous KOH, you form substitution reaction. CH3 CH2OH. If you use alcoholic KOH or ethanol KOH, then it forms CH2 double bond CH2. For aqueous KOH, the reaction is substitution reaction. For alcoholic KOH, the reaction is elimination reaction. This is the product, and this is Cl. You used alcoholic KOH. What will be the product? Hope you understand. If there is a hydrogen, if this HCl is removed from here, so the product will be this. That is 1, 2, 3, 4. But 1A. Butane. Or if you eliminate, there is a hydrogen. If you eliminate this HCl, you get this type of product. Also this product is called Hofmann product, and this product is called Sedgwick product. Sedgwick product is more stable, and this is the major compound. This is the major compound. Hofmann product always shown at the side of the element. This is 20% and this form 80%. So this is the major product. Sedgwick product is the major product. Okay. We can write this product into two ways. We can write in this way, or that the position of this bulky group and this bulky group is anti. So this is the trans product. So this product is trans-butene, trans product. Or you write in this both method 1, 2, 3, 4 the bulky group on the same position. So this is the cis product. So you can write this isomers also for this Z product. Okay, this is the elimination reaction. Elimination reaction are also classified into two parts. One is E1 and E2 as like SN1 and SN2. E1 and E2. Same. This is first point is this is unimolecular, not substitution. It is elimination. Elimination reaction. It is bimolecular elimination reaction. So E1 is unimolecular elimination reaction, E2 is bimolecular elimination reaction. And the second product is second reaction is it is two-step reaction. E1 as like SN1, it is two-step reaction, and this is single-step reaction. Okay, order and molecularity 1 and order and molecularity 2. This is the third point. And the fourth point is you can use C2H5OH plus heat as reagent, but you should use strong base as like alcohol-KOH. Okay, we can use here weak base, but you should use strong base for the E2 reaction. If there is E2 alcohol-KOH or the strong base, you guess this reaction is on the E2 reaction. There rearrangement possible. Methyl shifting, hydrogen shifting, rearrangement possible. Rearrangement for the E2 reaction impossible. So those are the basic difference between E1 reaction and E2 reaction. Okay. So what I get, or what are the summary of this reaction? The summary of this reaction is one is substitution reaction, that is SN1, another substitution is SN2, and one is elimination reaction, that is E1, and another is elimination reaction is E2. Two types of SN1 SN2 are substitution reaction, or two types of elimination reaction. SN1 and SN2 reaction. SN2 reaction is a single step reaction. It depends on the bond of the carbon X, nucleophile attacked here, and you get the simple product or inversion product of this compound. This is SN2 reaction. It is depending on the leaving group. As the leaving group is good, and this shown is better. This reaction is better for that case. It is depending on the 0 degree, 1 degree, 2 degree, and 3 degree. For less steadiness, it is better. On the other hand, SN2 reaction shows two types of formation or two types of mixture. NuCC. If you imagine a mirror, you get this compound, this plus this one compound and this two compound. If we mix up 1 plus 2, we get racemic mixture for this reaction. This is SN1 reaction, and SN1 reaction, for the SN1 reaction 3 degree is good, but for the SN2 reaction 1 degree is good. Okay. As same E1 E2, we need here C2H5OH and heat as the weak base for the E1 reaction. But for the E2 reaction, we used strong base act as like alcohol-KOH. How the elimination is formed? This I take this product Suppose this carbon has H, so the elimination is formed in this way by using alcohol KOH. So the product is this. So this is SN1 SN2 reaction and this is E1 E2 reaction. Okay. Thank you so much. Have a nice day. Bye.